In the Part 1 video that goes with this one, we discussed Python syntax for decision-making logic, Boolean expressions, and logical and comparison operators. Next, we'll see how ArcPy can be used to make decisions based on GIS data. First, let's examine why we care about describing GIS data by looking at an example. This example is displayed with a flowchart of a workflow. Like pseudocode, flowcharts are a way to express a workflow. They can be used alongside of pseudocode to describe a process. You've all used Model Builder. Model Builder is a bit like a flowchart that is capable of running the code. In the example shown here, the bottom line is calling some custom functions to do conversion of the input data. Before the conversion can be performed, the process needs to determine some information about the data. Generally, you read flowcharts from top to bottom. First, what's the data type? If it's feature class or shapefile, we go down the left branch of the chart and get the shape type. Instead, if it was a raster, we go down the middle branch and check the raster format. Otherwise, we're on the right branch, printing a rather rude message. On the second level, or third level, if you want to consider the top box a level, if we're on the left branch, we get the shape type, and then we call a different function depending on the shape type. Again, on the third level, if we're in the raster branch, it gets the raster format. Below that, it either stops or calls a convert to TIFF function. If you turn the whole diagram upside down, it would look a bit like a rather ugly tree. But you can see from this example why decision making is also called branching. To implement a workflow like this in Python, you need to be able to use code to answer questions about data characteristics such as, is this a feature class, raster, or something else? What's the shape type of a feature class? Point, line, polygon? What's the format of a raster? Is it a TIFF, a JPEG, an Esri grid?
There's something called the describe method. And that's on our cheat sheet here, describing data, and it's a function that you say arcpy.describe, and you pass in the name of the data that you want to describe. So here we're assuming we have a variable defined, so getty_rast or something. And what it does is it returns a describe object. In this example, we're going to import arcpy because we've got to use that describe. We've set up a variable to hold our data name. And this is, if you recall from day 2 or so, or day 1, we started talking about object.method and object.property. This is the same format we're going to use for the describe object. So we say arcpy.describe, and here arcpy is a module, and it's the object dot the describe method, and it returns a describe object. So this assignment statement puts the described object over here. So if we actually print out DSC in this example, we get this crazy statement here. Geoprocessing describe object, object at, that's just saying that there's some object in memory that we now have access to. So in order to use DSC, we don't use it directly, we use a dot, and we get at the properties that it has. DSC, if we get it this way, we say arcpy.describe and we pass in some data. We can say print dsc.data type, and that'll give you whatever the type is of that data set. So data type is one of those describe object properties that every described object will have. However, depending on the data type, other different properties will be available. So if the data type is raster dataset, then it'll have properties like band count, compression type, format, permanent, sensor type, do these make sense to you? You know, you're familiar with band count and those kinds of properties for rasters. So those are raster-related properties specific to rasters. Okay, if we said, if we had this data, the raster raster 1, and we said DSC dot shape type, we'd get an error. Because since it's a raster data set, it doesn't have that property. Okay? So that's where our conditional statements come in, because we can say, you know, if the data type is raster data set, then we can check the format. If the data type is feature class, then we can check the shape type. Suppose, for example, that you want to do what's on the left side in pseudocode. You want to get a shapefile, get the shape type, and that's where you use the thing that we just went over, right? The describe object. And then if the shape type is polygon, print shape is polygon. Else, if the shape type is line, print the shape is line. Else, if all else fails, just print the shape isn't line or polygon. Using what we went over just now, can you remember how that describe statement looks like? argpy dot describe. Can you write that down? So you're gonna use an assignment statement because you need to keep the describe object that it returned. Remember how it looks? So da 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 equals da 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 capital D. It's got to be capital D. And then it's got to be an assignment statement. So you're going to say something equals just whatever variable you want to name it. It's going to be your describe object. Okay? And then now, once you have your describe object, how can you get the shape type from that? Guess at how that would look. So once you have this statement, your statement should look something like that. Obviously, you don't have to have the same variable name. It doesn't have to be DSC. So it should be whatever your object is, dot. Okay, so it's a lower S shape and a big T. So it's lower camel case. And I just used a variable named shape type. This is arbitrary, whatever you want to call it. Okay? So now try to write the Python code for those conditionals. And you can say equals, so you're going to be checking if the shape type is equal to quote polygon or quote polyline. And remember the comparison operators that you just learned for equals. Don't forget your punctuations and your indentations. So first line should look something like this. And then make sure you have your some indentation there. And the next line should look something like this. And again, the indentation on the next line should look the same, lined up, right, with the previous print statement. And did everybody remember their colons? Colon after else, colon at the end of this line, colon at the end of this line. So the question is, how do you know? How do you know what you're looking for? Try it out and have it print out so that you can write your code correctly. Yeah. I mean, it's in the documentation, but it's probably faster just to run your code and have it printed out than to go and try to find it. We just went ahead and checked. We said dsc.shapetype, right? Without checking whether the thing is going to have a shape type or not. If you change this to a raster file name, it's going to give you an error when you get to this line. Huh? So then we should check first before trying to use. Yeah, I mean, we could use format, but we don't know ahead of time, right? So we need to use a conditional statement, right? So if the shape type, if the data type is shapefile, then we can go ahead and do all of this stuff, right? Otherwise, better not to do it. So we might have an else that matches this if, and then we say, And then we check the, if it's a raster data set, and then we check the format, and we print something else based on that. Just depends on what you want to be doing. But the key here is to, if you're going to use one of those specific to a data type things, wrap it inside of a conditional statement so that you have that safety, that checked before you try to do it. If there's some, input coming from the user instead of being hard-coded right here, then it needs to be flexible so that it doesn't break when you pass in some other kind of data, or it breaks gracefully. Yes? You can do data type. Data type is one of the, so if you look at this box here, the things that are outside here are free for any data type, right? Any data type will have a base name, it'll have a data type, it'll have an extension. But the things that are inside the dark green boxes are specific to those types.
You might be wondering how to determine which properties are available for a type of data. One approach is to look in the online help documentation. Though the pages are constantly changing, the online help, the basic content, and the structure of the describe object help has remained pretty steady. You'll find a summary page. If you search online with key terms describe object arcpy, the summary page shows you all of these properties that are common to any data set. There's a link from the summary page to another page that contains a list of all of the data types with their links to individual pages. So it's a long list of links. If you click on one of these individual page links, you can see the properties for that data type. Here's what we see when we have clicked the link to the feature class properties. The feature class has a feature class property, a has-in property, a has-z property, and so forth. The table, the column on the right, explains what each of these properties signify. Most data types also have links to other data types pages with whom they share the same properties. Shapefiles, for example, have the properties we just saw in the feature class page. They also have the properties that tables have, and they have the properties that datasets have. In fact, they don't have any other properties in addition to these. Any API that you learn is going to have similar property tables and documentation like this, so it's good practice to look around and explore this. All right, in this two-part video set, we have talked about conditional statements, decision-making syntax, Boolean expressions, logical and comparison operators, and the describe object. The next topic will be Python looping syntax.